Hello folks, let's be back with the next video of this problem number 9. Problem number 9 is not so straightforward. Uh, it calls for lots of simplification, and it's after that we can apply the formulae and get the problems done. So in the denominator you see a cubic. So it's very clear to us that this cubic has to be solved and then broken into factors, and then partial fraction has to be done. So let's start right away by considering the denominator. Let's consider the x cube minus x squared minus x plus 1. Let's break this into two parts and see what can happen. In the first part, you can have x squared common so that you're left with x minus 1. And in the second part, you can have minus 1 common, again left with an x minus 1. As a result, overall there is an x minus 1 common. So you have x minus 1 times x squared minus 1. Now x squared minus 1, it's of the type a squared minus b squared, which breaks as a minus b into a plus b. So this can become x minus 1 into x plus 1. When it breaks up as a squared minus b squared, breaks up as a minus b into a plus b. But when we do that, this becomes a repeated factor. So that's our work now. So what happens is, here we are having 3x plus 5 over now x minus 1 the whole squared times x plus 1, because it is broken up that way. And we know when we have a repeated factor, we'll have a times x minus 1, b times x minus 1 the whole squared, and c times x plus 1. We did it last time, so in the previous problem, so we know now how to do it. So in order to make this as the LCM, a will get multiplied with 1 x minus 1 and x plus 1, b will get multiplied by x plus 1, and c will get multiplied by x minus 1 the whole square. You have the denominator as x minus 1 the whole square times x plus 1. Here you have 3x plus 5 over x minus 1 the whole square times x plus 1. So this can get cancelled, and this is your existing term. Now from here, it is for us to find out the ABC value and then get across doing our problem. So let's start right away as to how to go about it. Let's check. Maybe x equal to 1 could be your first value. Let x equal to 1. When x is 1, just look at how it is. So if x is 1, maybe I can write it once. Your term will be a times x minus 1 x plus 1, first one, then plus b times x plus 1, and c times x minus 1 the whole squared equal to 3x plus 5. Okay, so let's make the substitution. When x is 1, this term and this term is vanishing, you're left with the b term. So b times 2 is equal to 3 plus 5, 8. So b value is 4. Then we have the next substitution. It could be x equal to negative 1. When x is negative 1, this term and this term will vanish. So you're left with the c times negative 2 the whole squared, which is minus 3 plus 5, which is 2. And this is 4. So c times 4, so 2 over 4, which is half. You get the c value as half. So also you have now to get the a value, but for that there is no substitution. Let's put x as 0 then. So if x is 0, a times, it's going to be negative 1. B, we know the value, it's 4. So that's 1. And c, we know it's half, times negative 1 the whole square is 1 itself. And on the other side, it's 5. So it's negative a 4.5 actually. So it's going to be 5 minus 4.5. Or you can actually write 9 over 2 and all that. Common sense, 5 minus 4.5 is going to be half. So negative a is half, a is negative half. So you've got all the three values. Now we can get back to the I. So I for us now is integral of a, which is negative half over x minus 1 dx. Then b, which is 4 over x minus 1 whole squared dx, c, which is half over x plus 1 dx. Now let's take these constants out. Negative half outside, integral of dx over x minus 1. We can have the 4 outside, integral of dx times, if you want you can call it as x minus 1 raised to minus 2. So that will give you the answer. And here you can take the half out. So you have integral of dx over x plus 1. Let's get the integrals on that. Negative half. This is log x minus 1, we know. And this is going to be 4, negative 4, because that contributes. So it will be negative 4 over x minus 1. And the next one is going to be half times log x plus 1 plus c. So these are the terms that we are getting it from here. That's it. So that's the integral for the 9th one. That should be all for the video. Next one is a voluminous problem. We will not be able to continue over here. So with the next problem, I think we can meet in the next video. As I always tell, please popularize the channel and spread a word. See that we are there everywhere. Thank you.